Hello everyone, I am Professor PANKAJ Sharma. I am here with design of transformer conceptual numerical. Problem number 2 is estimate the main dimensions including winding conductor area of a 3-phase delta star core type transformer rated at 300 kVA 6600/440 volt 50 Hz, a suitable core with a 3 steps having a circumscribing circle of 0.25 meter diameter and a leg spacing of 0.4 meter is available. EMF per turn is equal to 8.5 volt, delta is equal to 2.5 ampere per meter mm square, kW is equal to 0.28, SF is equal to, which is stacking factor, 0.9. Now we have to write first of all given data, which is 3-phase delta star 50 Hz 3-stepped core and current density, which is represented by delta is equal to 2.5 ampere per mm square, given it is core type, 6600/440 volt, rating is given 300 kVA, diameter D is equal to 0.25 meter, leg spacing 0.4 meter and kW is equal to 0.28. SF stacking factor is given 0.9. Now going to the solution. If possible, let 440 voltage be the secondary side and 6600 volt be primary side, as it is given. Primary is your delta and secondary is your star. Therefore, secondary voltage per phase Vs is equal to 440 upon root 3, which is coming to be 254 volt. Also, ES is equivalent to Vs. EMF per turn ET is equal to ES upon TS. Therefore, the number of secondary turns per phase TS is equal to ES upon ET. That implies TS is equal to 259 by 8.5, which is coming to be 29.88. The turns should be integral, so it is equivalent to 30 turns. Phase voltage ratio of transformer Vs by Vp is equal to 254 by 6600. Number of primary turns per phase Tp is equal to Ts into Vp upon Vs. Now Tp is equal to, put the values, 30 into 6600 upon 254 is equal to 779.5. Turns is again integral, so it is 780 turns. The kVA rating of transformer Q is equal to root 3 VLP ILP into 10 raised to power minus 3, and also Q is equal to root 3 VLS ILS into 10 raised to power minus 3, whereas VLP is equal to line voltage on primary side, ILP is equal to line current on primary side, VLS is equal to line voltage on secondary side, and ILS is equal to line current on secondary side. Now, line current on primary side ILP is equal to Q upon root 3 VLP into 10 raised to power minus 3 from the previous equation. Now putting the values, 300 upon root 3 into 6600 into 10 raised to power minus 3, which is coming to be 26.24 ampere. For 2-stepped core, Kc is equal to 0.56. Also, Kc is equal to Ai upon dA square. Hence, net core area Ai is equal to Kc into dA square. Put the values, 0.56 into under bracket 0.14 whole square, which is coming to be 0.01098 meter square. We can approximate this value by 0.011 meter square. kVA rating Q is equal to 3.33 F BM AI kW AW delta into 10 raised to the power minus 3. Put the values. Q is equal to 3.33 into 50 into 1.25 into 0.011 into 0.2 into 0.0144 into 2.5 into 10 raised to the power 6 into 10 raised to the power minus 3. On simplifying, it is coming to be Q is equal to 16.4835 kVA, or kVA rating of transformer is equal to 16.5 kVA on approximating the value. This is the result. Now this is the end of this problem. Now we'll go to next problem 3, whose solution will be provided in the next video lecture. Till then you have to think about this problem. You may try, but wait for my next video. I am giving the solution of this video. The problem 3 is, determine the dimensions of core and window for a 5 kVA 50 Hz single phase core type transformer. A rectangular core is used with a long side twice as long as short side. The window height is 3 times the width. Voltage per turn is equal to 1.8 volt. Space factor is equal to 0.2. Current density delta is equal to 1.8 ampere mm square. Bm is equal to 1 Weber per meter square. Try this problem at your home. This is very easy, and I am coming with the solution of this problem in the next video. Till then, thank you so much.